Welcome back. I hope you are doing great. In the previous lecture, we understood about the broadcast variables as a part of the distributed variables in low level APIs. Now, in this lecture, we'll understand more about the accumulators, which are there as a part of the distributed variables in low level APIs. We already have understood accumulators. Let us add together data from all the tasks into a shared result. We have already understood this in our introduction. Let us say you are updating a value as a part of your transformation. That value need to be updated like a counter. In that case, we can use the accumulators. Accumulators help to propagate the value inside the variety of transformations in an efficient and fault tolerant way. One of the important aspect is accumulators provide a mutable variable that Spark cluster can safely update on a per row basis. Pay attention here. I am saying a mutable variable. As we have seen, most of the core data structures of the Spark are immutable. But in this case, we are making a variable mutable so that all the results from the different executors can be updated to the accumulators. One more important aspect is these variables are added only through associative and commutative operation. That's the reason they can be efficiently supported in parallel. But what do you mean by associative and commutative operation? Let us spend some time there. It is important to understand these two properties. Most of you would have already understood as a part of your some mathematical lectures in your early days, but let us revise that. When I say associative property, what it means is when you want to do some operation, arithmetical operation, whatever the way you want to regroup the numbers, you will get the same answer. Let us take an example here. 2 plus 3 plus 4 is equal to 2 plus 3 plus 4. See, I am grouping here, I am grouping some other numbers here, but both of them are equal. That is what associative property states. How about the commutative property? In commutative property, whenever you are doing some arithmetical operation, even though you move around the numbers or change the positions of the numbers, yet the results will be same. Let us take an example here. 5 into 10 is equal to 10 into 5. You can see I change the position of 5 from first to last. Then change the position of a 10 from last to first. Yet the result remains the same. But why is it so important to have a associative property and commutative property for the accumulator variables? We'll see that. For accumulator, updates are performed inside the actions only. Spark guarantees that the accumulator will be applied only once. This is going back to our associative and commutative property, because accumulator variables are added only once. They are kind of confirming to the associative and commutative property. Spark is guaranteeing that update to the accumulator will be applied only once. Why is it important? That is because sometimes your tasks may be restarted, like if driver is restarted, or even the executor is restarted. In that case, you should not get the update to the accumulator again. That means one transformation has happened as a part of the E1. If it is already sent the results to the accumulator variable, after restarting again, it should not send the values. If it sends also, there should be a way to determine that this is not the value to be applied. That will change the overall result, right? That is the importance of the accumulators. Accumulators are one of the distributed variables. Just because accumulators are there which are mutable, that will not change anything the way Spark is working. It is still lazily evaluated. Accumulators can be both named and unnamed. If it is named, the accumulator will display their running results in the Spark UI. If it is unnamed, they will not display their names in a Spark UI. Now that we understood what are accumulators, let us take an example here. We'll understand the accumulators in a pictorial representation. Let us say you have a transformation 1, transformation 1, transformation 1, transformation 1, transformation in, which is happening in all the executors here on the partition data: partition 1, partition 2, partition 3, partition 4, and partition 5. So instead of sending the results to the driver, the results will be sent to the accumulator variable. So result from this plus 2 plus 4 plus 5 plus 6, like this it will be added, and we'll get a final result from a accumulator variable. Now that we understood how the accumulators work, we will take an example and understand it further. First of all, let us go ahead and create a data frame called df flights by reading a file, parquet file here. We have done this multiple times, so I will be able to do it very easily. Next one is we can create an accumulator that will count the number of flights to and fro from a country. Country being China. So we are creating an accumulator here. After that, we got to define a function that will help us to add to our accumulator. Here you can see we are defining a function named accumulator China function, and this is a variable, and we are assigning the value from one of the column to this variable and calling it as a destination. We're assigning another column value to this variable and assigning to origin. We are just checking if the destination is equal to China, then add to this counter. If the origin is equal to China, then add to this counter. So defining a function is one of the important aspects whenever we are using the accumulators. The next thing is we'll iterate over each row of the flights by using a for each method. What for each method will do is it will run once for each row in this data frame, and we'll run a function against each row and update the counter. That is, counter here means the accumulator variable. That way we'll understand how many flights are there which are destined to China and originating from China. We can get the accumulator value by using a dot value method. Wonderful. We have understood the concept of accumulator variable, which is interesting. And we looked at the example. When we see this example with the hands-on execution, it will be much more clearer. You have a wonderful time. Thank you.